Hey everyone, and welcome. So glad you're joining me for today's explainer, because we are going to unpack an absolutely staggering anomaly sitting right in our very own cosmic backyard. We're talking about our solar system's two reigning heavyweights, Jupiter and Saturn. Just to give you an idea of their sheer scale, if you put these two together, they hold over 90% of all the planetary mass in our entire solar system. 90%! Now, at first glance, these gaseous behemoths seem like pretty close siblings. But if you look just a little bit closer at what's orbiting them, a completely bizarre mystery pops up. Okay, let's just dive right into it. It's basically a classic tale of two planets. Take Jupiter over here on the left. It's practically its own mini solar system. It hosts an absolute multitude of satellites, famously including 4 massive ones: Ganymede, Io, and Europa. Fun fact, Ganymede is actually larger than the planet Mercury itself. Pretty wild, right? But then you look over at Saturn on the right. Despite being a similarly gigantic gaseous neighbor, Saturn's family photo looks completely different. It primarily hosts just one really massive moon, Titan. For literally years, scientists have been scratching their heads wondering why the glaring difference. How on Earth, or, well, how in space, could two planets so similar in size end up with such radically different moon counts?
Section 1. Simulating Planetary History. Looking into the past. To crack this case, an incredibly brilliant team of cosmic detectives from Japan and China, including some top-tier researchers at Kyoto University, turned to a massive Japanese supercomputer cluster. They quickly realized that just looking at the planets as they are today wasn't going to cut it. As this quote right here perfectly sums up, they needed, and I quote, a unified explanation relying on detailed numerical simulations of young planets' internal structures, tracing temperature and magnetic intensity. Basically, they hit the rewind button. They ran insanely complex calculations to reconstruct exactly what was happening deep inside these giants back when they were just cosmic infants. They weren't just looking at the surface, they were literally mapping out the internal heat and the magnetic forces churning deep inside. Now, to really wrap our heads around this, we have to look at the immediate environment surrounding these young planets, specifically something called the circumplanetary disk. Think of it as this massive reservoir of gas and dust swirling around a baby planet. It's essentially the planetary nursery where moons are eventually born. And here's the kicker. Early on, both Jupiter and Saturn had these massive swirling disks of raw material circling around them. So if they both had the exact same raw building blocks, why didn't they both get the same kind of moons? Well, this simulation data brilliantly illustrates the exact moment things started to go sideways. Notice Jupiter down there in the bottom left? You can see a distinct, dark, visible gap, almost like a cavity directly around the planet, cutting right through that dusty disk. Now, look up at the top right at Saturn. Notice anything missing? It does not have that empty space. Its dusty disk goes right up to the planet. This single, glaring visual difference in the simulation is the ultimate key to our entire cosmic mystery. Section 2. The magnetic shield effect, creating a safe haven. So what's actually causing that giant, empty gap around Jupiter, but not Saturn? Well, it comes down to what's happening deep within the cores of these planets, where liquid metals are constantly churning and moving around, generating massive magnetic fields. A really powerful planetary magnetic field can actually act like an invisible shield. It interacts with its environment to create what scientists call a magnetic cavity. This is a specific, super safe region within that gas disk, carved out simply because the magnetic force is so incredibly strong that it literally repels the solar wind and shoves the surrounding matter away. So the crucial point here is exactly how this cavity functions as a safe haven. It basically operates in 3 key steps. Step 1. The planet's intense magnetic field acts just like a cosmic bouncer, completely repelling the disruptive solar wind. Step 2. This action carves out that safe, quiet cavity right in the middle of a totally chaotic disk. And step 3, because this area is totally protected from violent dispersing forces, chunks of matter can safely aggregate. They clump together and grow peacefully over time into large moons. It's basically the perfect, undisturbed incubator. All right, so let's put our two planets head-to-head again, but this time with our new understanding. Early Jupiter, it had a spectacularly powerful magnetic field. It successfully created that protective magnetic cavity, which trapped and preserved all those growing moons. That's exactly what allowed giants like Ganymede, Europa, and Io to form and actually survive. But then we have early Saturn. Saturn had a significantly weaker magnetic field in its youth, and because its field was weaker, it utterly failed to form that cavity. Without that protective shield, the materials in Saturn's circumplanetary disk were fully exposed to all those dispersing forces. The building blocks simply blew away or spread out way too thin. And that drastically reduced Saturn's chances of forming and keeping multiple massive moons. Case closed.
Section 3. Predicting alien moon systems beyond our solar system.
Now, this incredible breakthrough does way more than just solve a local mystery. It fundamentally changes how we look at the entire galaxy, giving us what's basically a new exomoon rulebook. First rule: if we find gas giants out there that are the size of Jupiter or larger, there is a very high probability that their strong magnetic fields allowed them to develop compact systems with multiple moons. Second rule: if we find planets around the dimension of Saturn, they'll likely only host 1 or 2 moons at most, all due to that lack of an early magnetic shield. And third, astronomers now have a literal treasure map. They're actually planning to apply these exact findings beyond our solar neighborhood. They'll be actively searching for these specific cavity signatures in the disks of gas and dust observed around distant exoplanets. Spotting a cavity in a distant star system? That could be the glowing neon sign pointing straight to hidden extrasolar moons.
Which leaves us with this final, thrilling question to ponder. If we discover a brand new Jupiter-sized exoplanet tomorrow, just how many hidden moons are waiting in its magnetic safe haven? By understanding the invisible magnetic shields right here in our own cosmic backyard, we've literally just unlocked a brand new way to imagine the unseen worlds orbiting distant stars. Thank you so much for joining me for this explainer, and hey, keep looking up.